C class, Taha, one thing. In this batch, we are at superposition principle. So as I was mentioning you that Coulomb's law in electric field are left, that as a backup we'll be covering in the different class. In this, we have to cover this chapter. So till the time Rafia is joining and let me get information about her. You all please copy till here. And then this question. Then I'll discuss it. I think Sufyan has written this part also. Taha, you just
Yeah.
copy. Let us see the application class. So in the last class, we've studied that a point where net electric field is zero, or net force is zero, we say that is a neutral point. Right now, we have to identify what is the location of this neutral point. So we have just taken x separation from this. See, this is given in the question that two charges plus 4e and plus e, they are separated by the distance a, right? So we have taken a separation x from plus e, right? This x is being taken from plus e. So if total was a, x has been taken, so we'll be left with a minus x. So let's say a minus x is separated from, this is the separation from plus 4e, and this is x. Now, this is the formula, Taha, we have discussed in the last class. You already must be knowing it. Kq by r square. It's the electric field due to a point charge. So at this point, we'll calculate the electric field due to this plus E. So K, what is Q here? It is E divided by R square. What is the separation here? X square. Similarly, what is the electric field due to this? K, what is the charge? QE, 4E. And R square, A minus X whole square. So at this neutral point, both the electric fields are equal. KE by X square, K into 4E by A minus X square. KE get cancelled. For this term, we will just take the root. That is 2, here x, here a minus x. And then we have cross multiplied it. So we will get x is equal to a by 3. If x is equal to a by 3, then this will be 2a by 3. And one more thing, Taha, after this, Rafia has written already. For some bodies, electric field at the center is 0 for symmetrical bodies. So like this was symmetrical, plus E here, plus E here. So we say net electric field at the center is 0. All right. And if a triangle is present, let's say triangle is there. So plus Q, plus Q, plus Q. And at the center, we have 0. 4 plus Q, these are present. So at the center, like pentagon, hexagon, octagon, nanogon, all these symmetrical figures. Symmetrical means all the charges will have to be identical. Then only we'll have this. All right. And for ultimately, it will lead up to the circle. At the center, we'll be having net electric field 0. This you can copy down later, Taha. First, all of you start writing from here. See, you have to calculate the electric field at the center. Now, this is one example that is very helpful in understanding the vectors also. So all those who have forgotten vectors, this is helpful. Though if you want, as I've mentioned, bridge course was over. But if you want one separate class, I can take. Now see in this square, basically 4 charges are present. Plus Q, plus 2Q, minus 2Q, minus Q. And all of these have their sides as A. So we have to find out the halves of the diagonal because at the center we have to find out electric field. So if you look at this big triangle, this is A, this is A. So this is the hypotenuse. So it will be under root A square plus A square. So this becomes root 2 A. So all these sides are A root 2, A by root 2, A by root, half of it. Fine. This entire big side is A root 2. So half of it will be A by root 2. So this is A by root 2, this is A by root 2, this is A by root 2, like this. All right, so this is all about the diagonal. Now come to the individual electric fields. If Q is the charge, A by root 2 is the separation. So how do we write the electric field? Look here, this is always the generalized formula of electric field, KQ by R square. So if you put it here also, this becomes KQ by R square. So R is A by root 2 whole square. For plus 2Q, it will be K into 2Q divided by A by root 2 whole square. For this, it will be K into 2Q. We will not take minus because we always take the magnitude. And here it will be KQ by A by root 2 whole square. Like this. Now see. For positive charges, electric fields move away. So for plus Q, it is moving away. For minus Q, it is getting attracted. So two electric fields here. For plus Q, it is moving away. For minus Q, it is getting attracted. So EB away, ED towards. Like this, two electric fields over here. What is the net electric field in this arm? We will add these two. For this arm, we will add these two. So these are the individual. Look here. These are the two arms which we are left with. ED, EB on one hand and EA, EC on other hand. All right. So this is one electric field E1. This is second electric field E2. So we have this with us. We have this with us. So when we add EA and EC, we get 6KQ by A square. And when we add EB and ED, we again get 6KQ by A square. So 6KQ by A square on this arm, 6KQ by A square on this arm. And they are separated by 90 degrees, right? So see, this will be E1 square plus E2 square plus 2 E1 E2 cos 90. Cos 90 is 0. So this is under root E1 square plus E2 square. This gives us root 2E. And what was the value of E1? KQ by A square. So final answer is 6 root 2 KQ by A square. This is for the purpose of 90-degree in parallelogram. Write it, and whatever, at whichever step you're not understanding, please let me know. Is it clear till here to both of you, Taha and Sufyan?
Yeah.
Okay, right. This is just for the backup purpose we are doing because as I've mentioned, Taha, because you are new here. So right now everything is written. This is from the notes which was done in the earlier batch. When we'll start from capacitance, there I'll be writing everything. Here we just have to quickly complete till electric potential part. That's why this chapter. Not this chapter from electric flux, writing down everything. This is just because we are completing some backup. That's why we are hurrying up with it. And I'm not writing everything. This portion. I'll be writing the notes again. Class, now the next topic is about dipole moment. But before we understand what is a dipole moment, you should know what is a dipole. And before you know that what's a dipole, you should understand what is a monopole. So stop writing and just listen. Monopole means mono means one and pole means polarity. So if a system is there which is having one type of charge, we say it's a monopole, means having a single polarity. So monopole, one polarity. So system having only one type of charge, either positive or negative. Like the best examples we have electrons. So electrons are what? Electrons are negatively charged and they are just negatively charged bodies. What about protons? Protons are completely positively charged bodies, right? So electrons and protons, they are monopoles because they have a single polarity. Then we calculate the strength of the monopole. That strength of the monopole is called the monopole moment. Fine. Now what's a dipole? If monopole is a single charge present, then dipole should be two charges present, two opposite charges present. So the base is right that yes, two opposite charges are present, but there's a certain condition to it. What's the condition? The condition basically says that positive and negative should be there, but they should have the equal amount. It is saying equal amount of positive and negative charges at a small separation. Both of these charges should be separated by an equal amount. Also, they should have a small separation. So what's the condition for a dipole? Dipole is a system having two equal amount of charges. Means if one end has 2 microcoulomb, this cannot have -4 microcoulomb. If this is 2 microcoulomb, this is -2 microcoulomb. If this is +4 microcoulomb, this is -4 microcoulomb, like this. So plus q minus q separated by a small separation, and that small separation we call 2a. Now let's come to the dipole moment. What's a dipole? Dipole moment will give us the strength between the two dipoles. That is the strength of this dipole. Now, how do we calculate it? We take any of these charges because both the charges are same. So put the value here, Q, and multiply it with the separation. Now, class, here it is written 2a. So by convention, we have been writing 2a. 2a does not mean that we are writing the value and multiplying it by 2. No. 2a means separation between both the charges. Both the charges which are separated by a distance, that distance we call it as 2a. So it's the separation between the charges. So vector quantity, so definitely it will be having magnitude. Direction, sorry, magnitude is there and direction. Direction is from the negative charge to the positive charge. From negative to positive. SI unit will be C. Charge is coulomb. Separation is meters. So this becomes coulomb meters. So what is, I'm repeating everything. Now hear me again. Monopole. Monopole means a single charge having single polarity. A single entity having a single polarity. Next we have monopole moment. Monopole moment means the net charge when we are calculating. Monopole means the net charge when we are calculating, or you can say the strength of a single charge. Then we have dipole. In dipole, we have two opposite charges present. They have the same magnitude but opposite signs, and they are separated by a small separation. And how do we calculate this dipole moment? We take any of these charges and we multiply it with their separation. Direction is from negative to positive. SI unit is coulomb meter and it's a vector quantity. Start writing it from here, class. If you've completed it, you can leave. Now we'll discuss rest of the things in the next class now. Thank you, Sufyan and Taha, for joining.